Hello students, in this video we'll see how to adjust the effective annual rate of interest for inflation. So if I'm given a collection, or in the parlance of economics, a basket of goods with total price P of T, then, of course, T stands for time here. That's the price of time T. Then P of T2 minus P of T1 over P of T1 is the effective rate of inflation over the interval T1 to T2. Okay, so in other words, you figure out how much the price has gone up or down potentially for deflation. If the numerator is negative, you get deflation. If the numerator is positive, you get inflation, right? And so this has exactly the same formula as what you expect from a cumulative rate of interest, right? So I'll get A of T2 minus A of T1 over A of T1. That's the effective annual rate of interest that you earn on an account, right? So this is your interest, effective annual interest. So they have the same form. And so how does inflation affect the overall rate of interest, right? So if we call this rate over, so let's look at these different rates over here. So I'm going to call this rate over here a rate of R, and I'm going to call this rate over here a rate of I. Okay? So we have rates of R for inflation and I for effective annual rates of interest. So here's the idea. So if P dollars buys N goods of a particular class, then $1 buys N over P of the good. So think about this. If $10 bought two goods, so just think about it from this perspective. If $10 buys two goods, then $1 buys a fifth of a good. That's how we want to think about it, okay? Now what happens when inflation strikes? When inflation strikes, you need more money to buy the same amount of goods. So after inflation, $1 buys N over P, 1 plus R of the goods, okay? In other words, you need more money, so the more money you get, and what's going to happen over here is this is going to make the whole expression what? That makes the whole denominator larger if you multiply P by 1 plus R. And so you're making the denominator bigger. When you make the denominator bigger, that makes the whole expression smaller, right? So if I go from 3/5 to 3/8, 3/5 is obviously bigger than 3/8. So as you make the denominator bigger, this whole thing gets smaller. So maybe we'll buy fewer goods over here. So there's fewer goods that I buy after inflation. But the good news is that after inflation, after a period of inflation, effective annual rate of annual inflation, this $1 is no longer a dollar. It's 1 plus I, right? So after interest, we have not just $1, we have 1 plus I times $1, right? So I'm able to get a 1 plus I on the top over there. So the effective, so I have a 1 plus I in the numerator and a 1 plus R in the denominator. So adjusting for inflation, effective interest for inflation, we have the following formula. We have that 1 plus J, that's going to be your new effective annual rate of interest after inflation, is equal to 1 plus I. 1 plus I be the ordinary rate of interest that you gain, but you're penalized by this 1 plus R for inflation. So the 1 plus R is making the 1 plus I factor cumulatively smaller. So J is the effective annual interest after inflation. So if you're trying to build in models of figuring out how much money you're going to accumulate in a bank account over a period of time, the bank account will give you an effective annual rate of interest. If you can model based on what the Federal Reserve is doing and the inflation numbers in the economy, you can take that effective rate of inflation and you can divide your 1 plus your effective rate of interest by the 1 plus the effective rate of inflation to figure out what the actual 1 plus your effective annual rate of interest is going to be. So this J is more powerful than just the I by itself because the J actually accounts for inflation. So this 1 over 1 plus R is sometimes called the inflation adjustment factor for the effective annual rate of interest. Thank you very much.